everybody, it's Miss Mello, and today I will be teaching you Lesson 8, which is on equivalence with factoring. To make your life easier, make sure you have the packet in front of you, so as I'm talking through it, you can follow along. There will be times throughout this video where I ask you to pause it so you can practice the skills that you had just learned. When you feel confident, hit play and we can resume the video. Remember, this is a video, so you can always pause the video, go back, and listen to any examples that I have already gone over to refresh your memory if you had forgotten it or needed an extra look at it. So, at the top of this page, I have some vocab here. Factors. Factors are the numbers being multiplied together. Greatest common factor, or also GCF, that's the greatest number or value that is a factor of two or more numbers or variables. And then we have coefficients, which are the numbers in front of the variables. So, finding the greatest common factor means taking out the largest number or taking out the largest variable in each term. So we're going to look at example 1. Find the GCF of 6 and 24. Now I wrote there, think to yourself, what number can be divided by each number evenly? That's what we're doing. We're taking out the largest number. So if we break this up, we look at 6. What numbers multiply to get 6? 2 and 3. We can't split those up because those are prime numbers, so we keep it like that. Then we look at 24. We can split 24 up into 2 and 12. Then we can split up 12 into 3 and 4. And 4 we know is 2 times 2. So we just created a factor tree of 6 and 24. Now, finding the GCF, we have to see what they have in common. 6 has a 2. 24 has a 2 as one of its factors. 6 has a 3. 24 has a 3. So since they both have a 2 and a 3, we take 2 times 3, which equals 6. So our GCF is 6. So again, we wrote the prime factors of each number, figured out what they have in common, and then that becomes our GCF. Looking at example number 2. We have find the GCF of 10 and 35. So again, we're thinking what number can be divided by both of those evenly. So we take 10. We know 10 is 2 times 5. Then we take 35. We know that could be 5 and 7. 5 and 7 are both prime, so we can't break that up into any other factors. Now we look, what do they have in common? A 5 and a 5. Since there's nothing else in common, the GCF is 5. Now at this point, I want you to pause the video and try examples 1 and 2. So you can go ahead and pause the video. Alright, so since you have taken the time to try numbers 1 and 2, the answer for number 1 was 9. So the GCF of 27 and 63 is 9. And for number 2, the GCF of 18 and 30 is 6. So hopefully you guys did that good. Alright, so earlier this week you did equivalence with multiplication. So let's recall the distributive property. Distributive property means we take whatever's on the outside and distribute to the parentheses. So we would distribute the 5 to x and 5 to 2, which would get us 5x plus 10. So let's simplify these three right here. If we distribute the 6 to the 5x, we get 30x. Then you distribute 6 to the negative 2, and we get negative 12. Then we look at the next one. Distribute x to 4x, you get 4x squared. Distribute that x to the negative 2, and you get negative 2x. Last one, we have a negative 2 on the outside. So you distribute that to x, negative 2x, distribute to the 7, and you get negative 2x minus 14. So why did I have you to do that? Factoring is the reverse of multiplying. So we are going to undistribute. Right here we just distributed. When we factor, we're undoing that process. So we are going to be given a product that looks like this, and we got to figure out what two things multiply together. Those are our factors. Okay? So we go to the next page. we have factoring using GCF. We know GCF is what? We want to figure out the greatest number or variable that is a factor that we can pull out. So example 1, we have 5x minus 35. Step 1 says we look at the coefficients. So we have 5 and a 35. Is there a number I can divide 5 and 35 by evenly? We know 5 is already prime. Then we look at 35. We make our factor tree. What do these two have in common? A 5. So we know the GCF is 5. Step 2, look at the variables. There's only one variable in this equation. There isn't one here, so that means we can't take out a variable because it's not with each term. So we're not going to do anything for step 2. Step 3, identify the GCF and divide. We identified that it was 5. So we're pulling out a 5. And then what do we have left? If we pull out a 5 from here, we divided 5x by 5, we have x left. Then if we divide by 5 here, we have a negative 7. So your answer is 5 parentheses x minus 7. So I want you to pause the video here. Try examples 1, 2, and 3 on your own. So you should have tried these examples on your own, hopefully. I will go over these answers with you. Example 1, the GCF was 12. So when we pull out 12, we have 12 parentheses x plus 2. Example number 2, the GCF was 6. So we pulled out a 6. So we had 6 parentheses x minus 5. Then example 3, the GCF was 8. So we pulled out an 8, so we have 8 parentheses x plus 88. So if you ever want to double check your answers, use Desmos, our tools, right? Plug your original equation into Desmos, then plug in the one that you came up with. If they're equivalent, they are on the same exact line. So make sure you look for that if you plug it into Desmos. All right, example number 2. This one looked a little different. We have 3x squared plus 27x. So again, step 1, look at the coefficients. We have a 3 and a 27. What can be divided by 3 and 27? 3 is just 3 times 1. 27 is 3 and 9. And 9 can be broken up into 2 more 3's. So what do these have in common? They both have at least 1 3. So that becomes our GCF right there. Then we look at step 2. Look at the variables. We have x squared and x. So that means that since both of them have at least one x, we can pull out an x from there. So then we move on to step 3. Identify the GCF using steps 1 and 2 and divide. So we know the GCF was 3, and we know we can pull out an x. When we do that, we have 3x squared divided by 3x. We have 1x left. Then when we do 27x divided by 3x, what do we get? We get a positive 9. So our answer is 3x parentheses x plus 9. So I want you to pause the video here and try examples 1, 2, and 3 on your own. All right, so you should have tried these already. The answers for them would be 6w, w squared minus 6. So we could pull out the 6w from that entire equation, and we have w squared minus 6 left. Second one, we have 18 cubed minus 6 q squared. So the largest thing we could pull out was 6q squared. So we'd have 3q minus 1, because we know negative 6q squared divided by 6q squared is just 1. And example number 3, we want to pull out a 9y squared. So we have y cubed plus 2 left over. And again, if you have any questions on this, your teachers are always there to help you through email, Remind, or Google Classroom. Or pause the video and go back to the example and slow it down. All right, example number 3 for factoring using GCF. We have 8a cubed plus 16a squared minus 12a. So again, our first step, look at the coefficients. We have an 8, 16, and 12. So we want to break those up. So we have 8. 8 can be 2 times 4, and 4 is 2 times 2. So we know the factors of 8 are 2 times 2 times 2. Then we look at 16. 16 can be 2 and 8. We already know 8 could be 2 and 4 is 2 and 2. Last, we look at 12. Split that up. 2 and 6, 2 and 3. So now we have 3 numbers. We need to see which ones have the same numbers for each one. So 8 has 1, 2, 16 has 1, 2, 12 has 1, 2. 8 has another one, 16 has another one, and 12 has another one. So our GCF here is 2 times 2, which is 4. Okay? Because each of them both had 2 in our factor tree. Now we're going to look at the variables. Since each term has at least one a, we know that we can pull out one a from each one. So when we do that in our step 3, we know our GCF is 4a. When we take 4a out of here, we have 2a squared left. Then we want to take 4a out of 16a squared, which is 4a. And then we take it out of the negative 12a. So if we take negative 12a divided by 4a, we get negative 3. So this is our answer right here. 4a parentheses 2a squared plus 4a minus 3. So at this time, you can pause it and try examples 1, 2, and 3 on your own. All right, example 1, you should have gotten these answers. Pull out a b, and then you have b squared plus 5b minus 20. Example number 2, you pull out a 2p, and you have 2p cubed plus 6p minus 9. In example 3, you pull out 4x, and you have 3x squared plus 6x minus 4. So that is all the notes on factoring using GCF. Now we are going to move on to the next page, which is factoring by grouping. So we are going to use this when we have 4 terms in our polynomial expression. This is our polynomial expression. We have 1, 2, 3, 4 terms. So our step 1 is we need to make sure that the polynomial is in descending order, which means it's the highest exponent first, then the second highest, and the second lowest and to the lowest, okay? So since that's already done for us, we don't have to do anything for step 1. Step 2, we want to split the polynomial into 2 different sets of terms. So what that means is we are going to break these up like this. So I put parentheses around the first 2 and parentheses around the second 2. Then we look at step 3. This looks just like what we were doing before on the other page when we just had something like this and we had to factor something out. So we know how to do this. What is the common factor here? The GCF. We can pull out an x squared. Because there's 1 here and 5 here, we can't take out a number. We can only take out the x squared. So if we take out x squared from here, we have an x left over and a 5 left over. Then we look at this one. 3x minus 15. What can I take out from that? Both numbers can be divided by 3. So I'm pulling out a 3, and I have x minus 5 left. Now, looking at this, what do we see? We see we have x minus 5 and x minus 5, right? So since those are in common, we're going to write those down here. Then what do we do with this x squared and 3? We are going to put those in parentheses as well. So x squared plus 3. So then our answer is this. Those are our factors to get this polynomial. X squared plus 3, and then x plus 5. So if we look at example number 2, we have 4x cubed plus 2x squared minus 2x minus 1. So again, we're going to break these up into two terms. Sorry, step 1, they're already in descending order. I did that for you guys. Step 2, we split them up into two terms. Then step 3, we want to factor each side separately. So what can I pull out of 4x cubed plus 2x squared? I can pull out a 2x squared. If I do that, what's left here? 2x plus 1. Now this one has a negative 2x minus 1. Can we pull anything out of this? Some people might say no, but what they both have in common is a negative. So we're going to take out a negative 1. If we do that, we just have 2x plus 1 left over. And again, we have 2x plus 1 in parentheses. And then we have 2x squared minus 1 all on its own. So that becomes one of our factors here. And the other one is the 2x plus 1. So then that is our answer. So those are our two factors to get this polynomial. Now here, I want you to pause the video. Sorry, I keep making it go diagonal. Pause the video here. Try those two examples on your own. All right, so if you tried those on your own, you should have gotten, I can't find my notes here, you should have gotten these as your answers. 3x squared plus 4, 3x plus 2, and then 8r squared plus 1, and r minus 8. Okay? And again, as always, you can double check your answers using decimals. Plug in the original equation and the one that you solved for. If they overlap, perfect, they're equivalent, you solved it. Now, you can go ahead and pause the video here because I have 8 practice problems for you to try. This is going to review the skills for using GCF and by grouping. So you can pause it now, or you can keep going on with the lesson and come back to that later. Whatever you choose to do. All right, if you paused it, welcome back. If not, we're going to keep rolling. So we have factoring trinomials now. We are going to use this when we have a polynomial that looks like ax squared plus bx plus c, where a equals 1. Okay? So where that a equals 1, we're just going to end up having an x squared. So it's like a 1x squared, but remember, we don't really need to have to write the 1, so it's just x squared. So our example here is x squared plus 3x plus 2. That's in the exact form that we need it to be, so we can go ahead and solve this using factoring with trinomials. So our step 1, always make sure it's in descending order, highest exponent to least. That is perfect. So then we move on to step 2. We want to identify A, B, and C. So using this right here, our A value becomes what? I said it should always be 1 when using this form. So A equals 1, because there's nothing there. We know that's a 1. Our B value is this middle value, which is 3. And our C value is a 2. So now that we have our A, B, and C, step 3 says we need to list the factors of C. Factors are what multiply together to get that number. So what are the factors of 2? 2 times 1. That one only has one answer. Step 4, we need to identify which factor adds up to B. Since there is only one pair of factors here, 2 plus 1, it adds up to 3, so that's perfect. So this is going to end up being our answer. How do we write it? Our answer, we want to make sure it's in factor form. So we want to put x plus 2, x plus 1. So your answer when you're doing this should always be x and then whatever these numbers were. So you should have 2 sets of parentheses with x in the front and then the numbers that you just got to add up to that b value. Example number 2. We have x squared plus 7x minus 8. So again, they're in descending order. Perfect. Step 2, identify A, B, and C. Our A value is always 1. Our B value is is this middle number right there, so that's a 7. And our C value is a -8. Make sure you include that negative in that because that is very important. So since we have that, we look at step 3. List all the factor pairs of C. So since our C value is -8, how can we get -8? What numbers multiply to get -8? Well, we know we can have 1 times a -8. We can have 2 times a -4. We could have 4 times a -2, or 8 times a -1. So we have 4 different pairs that we can choose from. We got to figure out which one will add up to our B value, because that is our step 4. So when we add these, 1 plus a -8, 1 plus a -8 gives us -7. Is that the correct, does that add up to our B value? No, because it's negative. Then we have 2 plus a -4. That gives us a -2. That does not add up to our B value. Then we have 4 minus 2, which is 2. Still doesn't add up. Then we have 8 minus 1, which gives us 7. And that is exactly what we want there. So then we put our answer in parentheses, and we have x plus 8 and x minus 1. So I want you to pause the video here and try the examples on your own. Alright, so these should have been your answers for those 2 problems. You should have gotten x minus 7 and x plus 5, and x plus 2, parentheses, x plus 9. So here again, I have more practice problems for you to try using the factoring with trinomials. There are only 6 of them, so take your time and solve them using the examples up here. And again, if you have any questions, email your teachers and they're happy to help you. Once you have finished all your practice problems, we thought it would be a great idea to show your new skills in a brochure. So we want to make sure in this brochure you include your proper vocab, terms, and definitions that we've gone over. We want to include factoring using GCF, factoring by grouping, and factoring quadratic trinomials when a equals 1, which is the last thing that we just did. For each of these 3 ways, make sure you provide the steps required to complete the process and provide 3 examples for each factoring way. Make sure you be creative with it, make it your own, and again, if you have any questions, contact your teachers through Reminds, Google Classroom, or email. Hope you guys enjoyed this lesson.